Assalamualaikum warahmatullahi wabarakatuh. Today I will be presenting to you on our group assessment about techniques of differentiation. Our program code is AS120 and our course group is A4AS120210. This presentation is prepared for Dr. Muhammad Hidayat bin Ahmad Kamal. So firstly, I would like to introduce you to the group members. I am Nur Amalina Amni binti Muhammad Nasir, and there is Fatin Alia binti Harun, and also Nur Aidatul Husna binti Abdullah Zawawi. So differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variables. In Calculus 1, there is 3 rules that you must know to solve questions involving differentiation. First is the product rule, second is quotient rule, and third is chain rule. So when do you use product rule? Product rule is used when there are two functions that can be differentiated separately. So the formula for product rule is dy over dx is equal to u dv over dx plus v times du over dx. Then there is quotient rule. Quotient rule is used to differentiate a function that is the quotient of two other functions of x. The formula for quotient rule is dy over dx is equal to v times du over dx minus u times dv over dx over v squared. Lastly, there is chain rule. Chain rule is used to differentiate a function of another function. The formula for chain rule is dy over dx is equal to dy over du times du over dx.
For the question 1, explain the meaning of differentiation and what are the techniques of differentiation. Differentiation is the process of finding the derivative of a function. The derivative of a function f at x is defined as f prime x equaling h to 0, fx plus h minus fx over h. This equation provides the limit exists. This method is called the first principle method. There are a few types of techniques of the differentiation. First, derivative of constant function c, derivative of a power function x power of n, derivative of sum and difference of function, product rule, quotient rule, chain rule, trigonometric rules, exponential rules, logarithmic rules, and lastly, implicit differentiations. For the next slide, we have some formula that contain for each type technique of differentiation.
For my part, I will be explaining the solution for question 2. So for question 2a, we need to find the dy over dx for the following function, 3x squared sec x plus 2. So we can see that for question A, there are two functions, 3x squared and sec x plus 2. Because there are two functions, we need to use product rule. So the formula for product rule is dy over dx is equal to uv prime plus vu prime. So then we will let u equal to 3x squared and v equals to sec x plus 2. To find the u prime, we just need to differentiate the u. So we will get 6x. And to find the v prime, we will use the chain rule because sec x plus 2 is a composite function. So we will get sec x plus 2 tan x plus 2. So then we will use the following things that we already calculated and we will apply it into the product rule, which we will get dy over dx is equal to 3x squared sec x plus 2 tan x plus 2 plus sec x plus 2 6x. And we can simplify this to become 3x squared sec x plus 2 10x plus 2 plus 6x sec x plus 2. So next, for question 2b, we need to find the dy over dx for the following functions. Y equals to 4x plus 2 over cos x. We can see that this function is a quotient function, so we will need to use the quotient rule, which is dy over dx is equal to vu prime minus uv prime over v squared. So firstly, we need to let u equals to 4x plus 2 and v equal to cos x. Then to find u prime, we just need to differentiate u, which we will get 4, and to find v prime, we need to differentiate v, which we will get negative sine x. Next, with the value that we have obtained, we will apply it into the quotient rule, which we will get dy over dx is equal to cos x times 4 minus 4x plus 2 times negative sine x over cos x squared. Next, we can simplify this to become 4 cos x plus 4x plus 2 times sine x over cos squared x.
I have to find the dy over dx using implicit differentiation for the equation y ln 3x minus e power 2x plus 1 minus tan for y equal to 0. We apply the product rule for the first term y ln 3x, so it's become dy over dx times ln 3x plus y over x. So the second term, using the chain rule, e power 2x plus 1 equal to e power 2x plus 1 times d over dx, 2x plus 1 equal to 2e 2x plus 1. Third term, tan 4y. Here we also use the chain rule. D over dx tan 4y equal to sec square 4y times d over dx. 4y equal to 4 sec squared 4y times dy over dx. So we plug everything into the original equation. We get dy over dx times ln 3x plus y over x minus 2e power 2x plus 1 minus 4 sec square 4y times dy over dx equal to 0. So we group the dy dx term together. Dy over dx ln 3x minus 4 sec squared 4y equal to 2e power 2x plus 1 minus y over x. So we solve for dy over dx. So the final answer is dy over dx equal to 2e power 2x plus 1 minus y over x over ln 3x minus 4 sec square 4y.
For question 4, use linear approximation to estimate the value of 4 square root 18.99 minus 2 over square root 18.99 correct to 3 decimal places. As we can see, they have different part of two functions. So for the step 1, let fx equal to x. We just substitute x in the value of the question. So we get x power of 1 over 4 minus 2x power of minus 1 over 2. And next we differentiate the value. And we get f prime x equals to 1 over 4 square root x power of 3 plus 1 over x square root x. For the second step, we have x naught equals to 81. Why we choose 81? Because the value is nearby with the given value. And x equal 18.99 and the next is delta x. We can get delta x from x minus x naught and we get 0.01. For the last part, we use formula linear approximation, which is f(x0) plus delta x equal f(x0) plus f prime x0 multiply delta x. And now we calculate each other. For the solution that I solve, we can get the final answer is 2.778.
In summary, differentiation technique like the power rule, product rule, quotient rule, and chain rule help us find the rate of change of function. This method, including derivative of trigonometric, exponential, and logarithmic function, are essential for solving complex problems.